right, so now let me talk a little bit about the cloud native capabilities. So I'm the exception to Darius's rule, where I will effectively talk a lot about not promises, but technology investments that we're making that are not proven yet per se, but that are certainly emerging as the way to move things forward. So I will give you a perspective on cloud native, because cloud native is obviously the way the world is moving forward. And if you are looking at cloud native, you need to think about applications are being developed now that we haven't seen before. We have seen applications obviously throughout the decades, but now we are seeing applications scale to unimagining numbers on the one side, meaning lots and lots of scale, but also scaling down when the resources are not needed. They're going down to the minimum amount of resources to service whatever the customers at this point in time need. And we now need to think about how do we implement those in this kind of capability, and how do we then build the assets that we have built over the years, how do we make them into this part of the cloud native capability? And obviously that's what this conversation is all about. Now, let's define what is cloud native. If you are following, go to slide 4. This is it. Yes, thank you. So cloud native is a set of concepts that the world has adopted as being part of the conversation of how you build applications for the future. The first one is more of a conceptual piece where you say we're going to have microservices, which are effectively small parts of code that are contained and managed in a consistent fashion, so that you have a fast change velocity, but also a small change vector, rather than monolithic applications that have a large surface area and that are hard to change. Now, if you think about building those microservices, you hear the terms DevOps and you heard the word container. So DevOps is the process of how you get to this capability of building smaller services that are agile and fast to change, fast to deploy, and fast to effectively learn from. And then containers are the way for people to package those applications and distribute them into the operating environment, be that a cloud, be that even a mainframe these days, or a on-premise environment. It doesn't really matter. All environments these days really support containers. With the triangle of microservices developed by DevOps, packaged by containers, you already have a very, very solid foundation. What's happening in addition, though, is that the world is moving to an API-first model, and APIs are really an expression of functionality that other people will build solutions against. And then you're adding a new programming paradigm that's called functions or Lambda, depending on which cloud environment you're on. Google and Microsoft call it functions. AWS calls it Lambda. But the idea is that you have a piece of code that reacts to external stimulus, mostly driven by events. Could be an HTTP call, could be an event from a storage system, and that piece of code gets woken up, runs, and then goes away. So this idea of a serverless operating model where you don't even think about packaging code, you just load the code into the cloud function. The function knows which triggers effectively go and activate it, and you then go from there, driving it forward. So from that perspective, it's really important to think through how your strategy with new code and existing code can take advantage of this set of capabilities that are really turning the world upside down. Just to give you an idea of why this is important, I have worked, or Microsoft has worked with customers in the e-commerce space, for example, where a customer using microservices and containers and Kubernetes as the next generation infrastructure was very happy that they were able to deal with the Black Friday surge of requests and demand. They were able to move to meeting the demand and doing it for a fairly affordable price, way cheaper than what they had been able to do before. The interesting thing, though, is that a similar retailer built the solution also on microservices, but augmented the capabilities with events and functions. And they were able to deliver the same kind of scalability, meeting the demands on the Black Friday retail environment with far, far less money. Because the functions are much, much smaller, much faster to run, and they only get built by the seconds they run. So composing the capability against this picture is really one of the areas of investment that everybody needs to think about for existing and for new code. How do you augment existing code with capabilities? And our Raincode friends have done an amazing job taking the mainframe assets, be that COBOL, PL1, or assembler, and augmenting them with modern functions, with being able to integrate in a microservices function-oriented world, and being able to deploy code in containers, participate in DevOps, and so forth. Now, let me talk a little bit about what all these pieces are. As I said to you before, you're seeing a cloud-native architecture. This example is on Azure, but you will find similar capabilities on all the other hyperscale environments. And we, as Microsoft, are investing deeply in all of these components because they effectively form the nucleus or the foundation of where investments are going to go in the future. How do you go and build these capabilities, scale them, bring them up and down, and also distribute them where you need them, because Azure might be your favorite place, but you might have on-premise environments, or you have investments in Google Cloud or AWS, and how do you effectively build code that then can take all of your operating models, be that, again, multi-cloud or on-prem, and run where you need to run them. And again, I'll show you a couple more examples of how this works, but wanted to give you a picture of how all of this can work using the example of Azure as the hosting environment. Now let's talk a little bit about what we are investing in to make life easier. So Azure Container Apps is a very new investment that we have made based upon listening to clients and customers about Kubernetes being a fantastic environment and certainly the investment of the future, but also not being the easiest to work with, and really challenging application developers and operations team with complexity that is very, very rich from a flexibility perspective, but it certainly challenges customers with respect to their know-how. Now we've built container apps to help developers really focusing on building applications rather than having to worry about how does Kubernetes work, what are the right investments in scaling Kubernetes up and down and so forth. And this container apps is an environment that we have, again, built to help you abstract some of the Kubernetes complexity or richness, depending on how you look at it, and have the developer focus on container applications. And I don't know if my friends from Raincode will show this today, but we have been working with the Raincode team to effectively go and have the assets that Raincode can build be hostable inside container apps. And container apps allow us to then be available anywhere you want to be, meaning on Azure, on AWS, on GCP, on premises in a VMware, bare metal, Nutanix environment, and so forth. Simply building applications that can run wherever you need to be able to run them. And again, our friends from Raincode have been doing some great work there. I hope that they will show it as part of this conversation. The next level that we have been investing in, now that you have an infrastructure called Kubernetes, you have a simplification model that deals with some of the richness of Kubernetes and simplifies it using container apps. Now you can say, how do I build or extend existing applications so that common problems like invocation of service to service are becoming effectively solved. And there is a CNCF, which stands for the Cloud Native Compute Foundation project, an incubation project called Dapper, the Distributed Application Runtime. And Dapper effectively allows an application developer to take a dependency on, for example, secrets management or observability management, and be then trusting that the hosting infrastructure, be that Microsoft Azure, AWS, Alibaba, or Kubernetes, effectively providing the necessary implementation so that you as a developer can focus on your code, requiring a certain set of functions, and again, being able to utilize the native hosting environment. So for secrets management on Azure, for example, you would use Key Vault. On Kubernetes, there is a Kubernetes native secret store that you would then be able to utilize, and you don't have to change your code, which obviously is important. And again, there is a very cool demo that Darius and team built of how you can extend and utilize your existing mainframe code using the Raincode applications and bring Dapper functionality in, so that a piece of Python code using the service-to-service invocation, for example, can work with your existing COBOL code as if it were a native function. So a really cool way of thinking about how you build applications. So now we have seen three pieces. We have a common infrastructure, Kubernetes. We have an abstraction that effectively allows us to build applications faster using the rich capabilities of Kubernetes without having to worry about the details, called container apps. Now we have an API surface that deals with common application scenarios that allows us to bring new and existing code together in a consistent fashion, while at the same time being optimized for whatever the hosting environment be that Azure, be that AWS, and so forth. Now, the last piece is, how do I take application capability that might not yet be reaching standard or that is proprietary to a specific environment? Now, Microsoft has been investing in Azure application services like App Service, Azure Functions, Logic Apps, and so forth, as part of our Azure application and cloud native investments. We're now taking those investments and making them available on top of Kubernetes, so that your applications that take advantage of Azure native functions like Azure Functions or Logic Apps or API management can now take those capabilities and bring them into a Kubernetes environment, which means on Azure, they run as serverless operated environments. On GCP, AWS, VMware, or whatever the environment is, as long as it can host a Kubernetes cluster or a Kubernetes environment, they can run inside that function. What that means is you now have rich cloud native function from Microsoft that can now run anywhere, and composing this together with Kubernetes, container apps, Dapper, and now you have Azure application services, you can build cloud native applications that were previously only available in a specific environment, be that Azure, be that AWS or GCP. Now you can have this wherever your code needs to run, be that inside a factory, be that inside a retail store or on premises or across multiple clouds. And we believe that combination will help all of you to build these cloud native applications, bringing existing assets using the Raincode innovations I referenced throughout the conversation, and modern assets that you're building from scratch together to really form the next generation application capabilities that you need in order to really compete, be flexible, be agile, and drive it from there. So with that, I want to bring the conversation back to Darius and team, but appreciate the time to be able to share a little bit about what is cloud native, how are we responding and driving investments against this, and I'm looking forward to the rest of the webinar. Thank you.